Okay, welcome to the homework 9 solutions video. Okay, we'll jump right in at number 1, and we want to expand the following sums. Okay, so what I mean by that is take the sigma notation, which is given, and write it out using just your normal sum notation, meaning with just a bunch of terms added together with pluses. I equals 3 to 8. And the sum end is 4i plus 2/3. Okay, so all I mean by this is just plug in I equals 1, or in this case, I equals 3, sorry, just the bottom bound here. 4 times 3 plus 2/3. Okay, so that's my first term. Plus 4 times 4 plus 2/3 plus 4 times 5 plus 2/3 plus 4 times 6 plus 2/3 plus 4 times 7 plus 2/3 plus 4 times 8 plus 2/3. And that's it. That's good enough. It just says expand and not to evaluate, not to simplify, nothing. So just take this as it is. Now this one is the one that I sort of made a mistake on when I was writing it. Of course, any of them could have had a 1 over I and would have been fine, but I had to pick this one. That's usually how it goes. So we'll just write something terrible. I'm already ahead of myself here. We'll write something terrible, and we'll write 1 over 0, though it pains me to do it. So first term is when I plug in 0, so I get e to the 0 plus 2. I'll even write that out. Plus 1 over 0. This is oof. And I'll have e to the 1 plus 2, but I'll just write that out as 3 plus 1 over 1 plus e to the 4 plus 1 over 2. And last one is e to the 5, which is 3 plus 2 plus 1 over I, which is 3 in that case. Okay, and you'll have to just take the 1 over 0 for that, just because I screwed up. Okay, and then for the last one, I equals 1 to 4 of sine of I pi over 2, I believe. Yep. This is plugging in 1. I get just sine of pi over 2 plus sine of 2 pi over 2, which I could just write as pi. But of course, I don't think you would have to simplify something like this. And if we wanted you to, we would explicitly say to simplify. But in this case, it doesn't really matter. I just want you to get used to the notation is all. 3 pi over 2 plus, and this would be 2 pi because it's 4 pi over 2. Excuse me. Okay, all right, moving on to number 2. This is dealing with the right Riemann sums. So for this one, we wanted to write down the right Riemann sum, approximating the area under, so write that as f of x squared minus 1 on the interval 2 to 4 with n equals 4 rectangles. And we're using right approximations, right endpoints. Okay, so let's remember area sub R is approximately b minus a over n times the sum I equals 1 to n. Ooh, of f of a plus I times b minus a over n. And this is just something that I have memorized, that you should have memorized. All right, and now we just start plugging in. So this is my b, this is my a, so I get 2 over n. In this case, n is 4. I equals 1 to 4. F of 2 plus, remember, b minus a over n is 2 over 4. So I get I times 2 over 4. So I can simplify. I get 1/2 f of 2 plus I over 2. Okay. And it also says to evaluate this thing, right? So I have to keep going and start evaluating. So I'll put this in parentheses just because it's going to get a little messy. And I get 2 plus I over 2 squared minus 1. Okay. And now we have to find what all of that is. So I have I equals 1 to 4. And let's multiply this out. I get 4 plus 2 times I over 2. So that just gives me an I. And then I get a plus I squared over 4. And then I get a minus 1. Okay, so another simplification. Let's just combine like terms before we start evaluating the sum. 4 minus 1 gives me a 3. So I'll get, let's say we write it this way, 1/4 I squared plus I plus 3. Okay, now normally if this was some arbitrary n and we didn't know what n was specifically equal to and we wanted to take a limit, then we would pull everything out and apply our sum rules and everything. But here, I think we can just do this explicitly because there's only 4 terms. So let's find out what each term is. 1/2 times the following. I get 1/4, this will be one term, 1/4 times 1 squared plus 1 plus 3. That's one term. 1/4 times 2 squared plus 2 plus 3 plus 1/4 times 3 squared plus 3 plus 3 and 1/4 times 4 squared plus 4 plus 3, right? All I'm doing is taking 1, plugging it in for I, 1 plugging it in, or 2 plugging it in for I, 3, and 4. Now I have to just add these all up. All right, so it looks like I get, just distributing through, I get a 4 plus a 1/4. Actually, I'll keep the distributing out of it for right now. So I get 4 plus 1/4 here, plus 4 times 1/4 is 1. So 3 plus 2 plus 1 is 6. 3 plus 3 is 6, plus 9 over 4. Okay, so I get 6 plus 9 over 4. 16 times 1/4 is 4, plus 4 is 8, plus 3 is 11. Okay, so I can combine my like terms. My whole numbers are going to be 10 plus 17 is 27, plus 1/4 plus 9/4 is 10/4. Now I can distribute the 1/2 through. I get 27 over 2 plus just 10 over 2. 10 over 8. What am I doing? Jeez. 10 over 8. 10 over 8, right? This can reduce a little bit. So 27 over 2 plus, divide both by 2, I get 5 over 4. That was what I wanted to do. Now multiplying this by 2 to get a common denominator, I get 54 over 4 plus 5. So this is really 54 over 4 plus 5 over 4. So that is 59 over 4. Great. So there's part A. Part B. write down the approximation for the function in A for n equals 40. So f of x still equals x squared minus 1. The interval is still 2 to 4. And this time n equals 40. And remember, we're still doing right. Okay, so area sub R is approximately b minus a over n. I would suggest you write this out every time, just to get the practice. To n, whatever it happens to be in that case, f of a plus I times b minus a over n. Great. B and A are still the same thing, but n should be 40 this time. So I get 2 over 40 times the sum I equals 1 to n of f of 2 plus I times 2 over 40. Okay, 2 over 40 can reduce to 1 over 20. And I get this. F of this thing, let's just simplify a little bit. This is 1 over 20, so it's f of 2 plus I over 20. And now the only thing we have to do is get rid of the f, right? Because we know what f is. N should be, in each of these cases, 40, because I know what that is. Forty, and 40. Great. Now I have 2 plus I over 20 squared minus 1, and that is the whole summand. And that's all part B is asking for there. Okay, so part C. We want to write a general expression using sigma notation for n subintervals. So we have the same f. We have the same interval, but we don't know what n is in this case. It's just a general thing. And again, we're using right endpoints. Okay, so notice that the instructions don't say to evaluate or simplify in any way. So we just have to do what we did for part B. So area using right endpoints is approximated by b minus a over n times the sum I equals 1 to n of f of a plus I times b minus a over n. Notice that I'm writing this out every time because it's something you have to have memorized, just like the definition of the derivative. So I have 4 minus 2 on top. 4 minus 2, I can handle that. It's just 2. And n stays the same because we don't have an explicit value for n. It's just n. And I have 2 plus I times 2 over n. Okay. So I get 2 over n on the outside. I equals 1 to n f of 2 plus 2I over n. And the last thing to do is just to plug in what f is, which is 2 plus 2I over n squared minus 1. And this is the whole summand. So I'll put it in brackets. And that's all I wanted for part C. Okay. Finally, on to number 3, just evaluate the integral from 0 to 3 of 3x squared plus 4x minus 1 dx by definition. Okay. So let's remind ourselves of the definition. Is the limit as n goes to infinity of b minus a over n times the sum I equals 1 to n of f of a plus I times b minus a over n. All right, now I can start plugging things in. B and A are 3 and 0 respectively, so I get 3 minus 0 on top, or just 3. Remember, n is still a general thing that I'm taking a limit of, so n has to stay in the function. The inside of f is going to look like 0 plus I times 3 over n, or just 3i over n. I get the limit as n goes to infinity of 3 over n times the sum I equals 1 to n of now 3 times 3i over n squared plus 4 times 3i over n minus 1. That's all on the inside. Okay. So I'm going to do the usual trick here and use linearity as I'm doing this work. So I'll keep the 3 over n on the outside and I'll put a big set of brackets around the sum stuff. It's a good tip for keeping things organized and remembering what applies to what. Okay, so for this guy, it looks like I get what? I get the sum I equals 1 to n of, this is 9i squared over n squared, and I multiply that 9 on the top by 3, so I get 27i squared over n squared. Okay, plus, and that only applies to this guy because I'm going to use linearity. Okay, here I just get 12i over n. Okay, and that only applies to that. Plus, I can pull the minus out, actually. I think we're grown up enough to be able to do that. I'll pull the minus out. I equals 1 to n of 1. And that sum applies only to the 1. All right. So now let's pull out anything that doesn't have to involve I in these things. So still my 3 over n on the outside. Pull out my 27 over n squared times the sum I equals 1 to n of I squared. And I should keep my parentheses. Plus, no, I had to pull stuff out. 12 over n looks like comes out of this one because 12 over n is the only thing that doesn't have an I in it. I equals 1 to n of just I minus, well, this one's already pretty much done. We took care of that in the last step. 1. Great. Okay. So now let's remember what our sum formulas are, because I know what this is, and I know what this is, and I know what this one is. These two being the easier ones, this one I probably have to think about a little bit to try to remember it, but I think we can figure it out. 3 over n times 27 over n squared times n plus 1 times 2n plus 1, I believe that's right, all over 6 plus 12 over n times n plus 1 over 2 minus n. Okay. So what should we do next? Let's try to cancel some stuff. So what am I going to have in this first term? Let me start writing on the next page, because I didn't really space myself all that well in the last one. 3 over n times this big thing. All right, let's figure out what our first term is. Well, I definitely have one of these n's are going to cancel here, right? Okay, so I'm just left with an n on the bottom. 27 over 6 is going to reduce as well, right? I can divide both of them by 3. So that is going to change into a 2. That is going to change into a 9. All right, so I have 9, n plus 1, 2n plus 1. 9, n plus 1, 2n plus 1 over 2 times n, right? Because I still have this n floating around. 2n. Okay, that takes care of one of them. This next term should be even easier. This is 12 over 2 reduces to a 6 over 1. This n and this n cancel, so I just have a 6 times n plus 1. 6 times n plus 1. And then I believe I just have a minus n. Yep. Great. Okay. All right, so now the only thing left to do, it looks like, is to distribute here in terms of simplifying inside the brackets. So let's do that. I'll leave the 3 over n alone until the very end. But I mean, you can bring the 3 over n in as soon as you like. There's not really a standard rule. The only thing is that you have to wait until everything's simplified to take the limit. That's really the only thing you have to worry about. But the 3 over n, you can bring that in whenever you like. So this is 9 times 2n squared plus 3n plus 1. 2n. 6n plus 6 minus n. Okay, 3 over n. And now I distribute the 9 through, so I get 18n squared plus 27n plus 9, all divided by 2n. Plus, I can combine the 6n and the negative n to get a 5n. And then I still have my 6. Okay, now I do the fraction splitting trick, where I sort of parse this out, and I'll do it in a separate step. Usually I would just skip over this and write out the simplified form. But since I'm benevolent, I'll write it out. Still 3 over n. All right, so I get 18 over 2, it gives me a 9, and one of the n's cancels. So I get 9n plus the n's cancel here, and I still get a 27 over 2. Still have my 9 over n, nothing happens there. Oh, that should be a 2n. Got lazy there. Then plus 5n plus 6. Okay, there's a little bit more combination I can do. Yeah, might as well do it. It's not super necessary, but let's make it as clean as possible before we take a limit. 9 plus 5 gives me 14. 27 over 2 plus 6 should give me 39 over 2. And then 9 over 2n just stays how it is. That is a 9, it looks like a 4. Okay. All right, and then we'll come up here and we'll distribute the 3n through finally. So distributing the 3 over n, 3 times 14 gives me what? 21 times 2, right? So 42, yeah. 42, the n's cancel, so this is just 42. 39 over 2, 39 times 3 is 117. So I get 117 over 2n plus 3 times 9, which is 27, over 2n squared. I take a limit of this whole thing. Okay. Now I apply the limit. 42 doesn't go anywhere. And this goes to 0, and this goes to 0. So I just get 42. And that is my final answer. Feel free to email me if you have any questions on this.